In this video, I will give a brief introduction to the collaboration project HiSS, Humanizing the Sustainable Smart City. My name is Hedvig Källström, and I'm a professor at KTH's School of Electrical Engineering and Computer Science, and the coordinator of this project. We have a homepage with the address shown here where you can find more information. HiSS is a highly multidisciplinary research effort ranging over 3 schools at KTH, and you can see the 7 collaborators here. The central goal of smart city development is the well-being of its citizens, and at the same time enabling a sustainable society and environment where resources are used in a balanced manner. And digitization is a key component of this, providing tools to collect information, connect people, and support decision making. Much earlier work on smart city development has focused on the system level, using a top-down perspective. But at the same time, there is a lot of work in other highly overlapping fields, such as cognitive psychology and neuroscience, econometrics, human-machine interaction, etc., on human behavior and decision-making, and how decisions on meso and micro scales interact and create emergent patterns on a larger scale. The central idea in HiSS is to employ such approaches from other fields for smart city development. We address 3 research questions. Firstly, which models are suitable for understanding human decision-making, decision processes, policy making, etc. in a sustainable smart city context? And secondly, we look at what aspects of human choices can be related to and explained by neurocognitive processes, that is, processes on a much lower level in the human brain. And how do social networks interactions on a higher spatial scale, on a maybe not city scale, affect human choices from smart homes to smart cities? So we look at what could be described as a meso scale, involving just a few people, to a macro scale, involving whole societies. In order to realize this, we have brought together a highly interdisciplinary research team, and we are in the process of exploring a variety of areas. So firstly, we have developed a coherent urban science theory basis for the novel bottom-up paradigm. So we go beyond conventional modeling and prediction, up in the yellow field here to characterize complex emergent adaptive systems. Secondly, in the orange row, we bring in methods from information theory, decision and control, human-machine interaction, artificial intelligence, and neuroscience for modeling of human behavior and decision-making at different scales, from neuro level up to city level, and employ them in the context of this new urban science theory. Last, we need to evaluate our models. For the smaller scale scenarios, so brain level models and interaction between pairs of agents, data and testbeds are readily available from other projects. So in HiSS we focused our efforts on slightly larger scale scenarios. So we have in the first 2 years focused on a testbed in connection to the living lab here at KTH. And we'll continue with this setting, but also move up to the city scale in collaboration with Stockholm Stad. Our work is focused around 6 case studies. A, knowing cities better through a new urban science, where we have developed the new urban science theory that I talked about. And here we also investigate how we investigate different digital tools for reasoning about human decision making, and see how they can be applied at various scales to produce new insights about urban dynamics. In B, we aim to examine cities as social networks, how human social choices define these networks, and how digital tools applied at various levels shape urban interactions. In C, we apply the findings from A and B to a real building scenario, the Living Lab, to model correlations between sensors and explaining behavior in terms of cause-effect relationships. In D, we aim to gain a better understanding how decision-making at a population and behavior at a population level could be explained in a bottom-up manner in terms of decisions being made by individuals and in interaction with each other. In E, we take even more one step down in spatial level and look at how neural information processes in the brain can explain the behavior of individuals. So there is presently no well-established theory how populations of neural cells can encode information about complex environmental stimuli, and how this relates to the behavior of the individual. And finally, in F, a newly started case study. We take one step up in spatial scale from C and look at a city level, and we're especially interested in how households and their practices in relation to digitization of the energy system and in the transition to a sustainable society. Presently, now we will move to look closer at one of the case studies, B. Let us take a closer look at one of these case studies and hear more about work done the work is done by Angela Fontan, who is a postdoc in HiSS, and her colleagues. In short, the context of this case study is smarter buildings, more specifically the Living Lab at KTH. And in short, the goal is to promote sustainable behavior of the inhabitants without compromising their life quality. So it's basically shouldn't interfere with their daily life. More formally, the goal is to examine cities as social networks of interconnected individuals, how human social choices define these networks, and how digital tools applied at various levels shape urban interactions and change. So this case study builds on the agenda proposed by case study A, namely to better understand human choices and actions in the context of evolving smart cities. However, while case study A focuses on psychological basis for individual decision making, drawing from, for example, behavior economics and social science, in this case study the focus is on human social interactions and extending the analysis to explore dynamics in social networks. And here we draw methodologies from the area of network control and dynamics over networks. I encourage you to come and listen to our seminar at the conference, and you will hear Angela talk more about this work in our breakout session.